Hello everyone, let's solve the 2006 AMC 12A question 4 together. There are a lot of ways to solve this question, but I believe that the most straightforward way is to use the multinomial theorem. And this theorem is just like an extension of the binomial theorem. So I'll explain this theorem later, and I'll also link the video to an explanation of the binomial theorem down below in the comments if you don't know what it is. So let's try to understand the question first. So here is the expression x plus y plus z raised to the power of 2006, and it's added with the expression of x minus y minus z raised to the power of 2006, and this is simplified by expanding it and combining like terms, and it wants us to find how many terms are there in the simplified expansion, and we can't just calculate the total number of terms because some of the terms will be cancelled out. For example, if we have x to the power of 1, y squared, z 2003, then it will be cancelled out with x to the power of 1 negative y squared negative z to the power of 2003, and they have complementary they're complementary terms, so their coefficient is the same. So we know that they cancel out. This is can be proven by the multinomial theorem, which I'll explain now. So let's say that here is a multinomial x plus y plus z, and it's raised to the power of n. So then here we have a summation for all of the possible values of a, b, and c, a, b, and c, and that add up to n, and the coefficient is n squared divided n factorial divided by a factorial, b factorial, c factorial, and then the term is x raised to the power of a times y raised to the power of b times x, z raised to the power of c. That was my mistake. Yes. So since there's actually like no extra coefficients we can find in both of the expression except for the negative signs, and n is equal to 2006 for both scenarios. So we know that the coefficient for these type of complementary terms are the same. This is why they cancel out fully. First of all, let's find the total number of terms before cancellation. If we want to find the total number of terms before cancellation, we can apply the stars and bars theorem. This is because it's a very straightforward way to find the combinations, and because we know that there can be two numbers with the same exponent, or some numbers can have an exponent of 0. So we need to use the second stars and bars formula. So it's 2006, which is the total numbers, plus the 3 extra slots we can have, because there are no restrictions saying like the exponents can be equal to 0 or they can't be equal, and we minus 1 because here it's the total number of options we can have, and we minus 1 because 1 represents the number of spaces we have, and we have 3 of these exponents, and we need to minus 1 for this. So it's the same as 2008 choose 2, and after calculation it's 2015028. So here is the total number of terms before cancellation. Now let's try to find the terms that will be cancelled. So let's refer back to the example I have raised over here. So we can see that a term will be cancelled when over here this term is cancelled because z is raised to an odd power but y is raised to an even power. So we can generalize it in this way. So a term will be cancelled when be cancelled when y is raised to an odd power and g is raised to an even power, or vice versa. So like that was the example I have given when y is raised to an even power and g is raised to odd power. Notice that x will not affect whether a term will be cancelled or not, because x is always positive in both of the scenarios. So now we can try to count the number of terms that will be cancelled. We can do this by casework. For example, when so firstly, let a be the exponent of x, b be the exponent of y, c be the exponent of g. Okay, now let's start to do casework to find the total number of cases when the exponents will be cancelled out. Firstly, when b is equal to 1, c should be even. So we know that the sum of the exponent a plus b plus c is equal to 2006 when b is equal to 1, a plus c is equal to 2005. For c to be even, you can have 0, 2, 4, 6, 8, up to 2004, which means that in total there will be 1,003 terms. Similarly, when b is equal to 3, c is even, so we can have 0, 2, 4, 6, 8, up to 2002. This time it's up to 2002 because similarly, a plus b plus c is still equal to 2006. A plus c this time, since b is equal to 3, will be equal to 2003. For c to be even, the largest possible value for c is 2002. This is why there will only be 1,002 terms when b is equal to 3. Now we can try to do this when b is equal to 5. Similarly, a plus c will only be 2001. So c can be 0, 2, 4, up to 2000. So there will be 1,001 terms. Now we can go to the last case when b is 2005, which is the largest odd number we can have. C can only be a 0, so there is only one case. So in total, when b is odd, there can be a total of 1 plus 2 plus 3 plus ... plus 1,002 plus 1,003 terms, which is equivalent to 1,003 times 1,004 divided by 2, because this is a sequence. However, we have not counted the case when it's y being raised to an even power and g being raised to an odd power, because they will be cancelled similarly. So the total number of terms cancelled is actually this expression times 2. So the total number of cancelled terms is 1,003 times 1,004, which yields to a total of 1,007,012. Now we can solve for a final answer by deducting the total number of cancelled terms from the total number of terms at first. So we have 6, 1, 8, 1. So in the total we have 1,008,016 terms. So our final answer over here is D. Thank you so much for solving this question with me, and I hope you enjoy this process as well.